All right, so today's topic is uses of minerals, and we're going to be covering gems, ores, and common uses of minerals in just normal life and a little bit inside your own body. So mineral resources. The average person uses 22,000 kilograms or 48,501 pounds of mineral resources each school year. And that's a massive number, so that's really tough to get in your head. So I have a little visual down here at the bottom. So you use it all the time in copper wiring and plumbing fixtures. Every time you use the restroom, you're using some minerals. Your phone has minerals laced throughout it so that it can connect to the Wi-Fi and the LTE cables and all of those other things in order for you to get on Snapchat all the time. So quartz is used in glass and ceramics. So I told you 48,501 pounds is really tough to visualize. That's 4 elephants, 4 grown adult African elephants worth of stuff. So you're using that many pounds of minerals each and every year of your life. Obviously, when you're a baby, you use less, and as you get to adulthood, you use a little bit more, but on average, 48,000 pounds. So gems, you've most likely seen gems before. Those are like the shiny rocks that are a lot of times transparent or see-through. You might wear them on like a bracelet or a necklace. You might see them on like old lady earrings, stuff like that. They're also called gemstones. They are highly prized minerals because they are rare and beautiful. Okay, a lot of things in nature are prized or collected because of their beauty. It's a lot of times why we have a lot of poaching, because elephant ivory is rare and beautiful, and tiger fur. It's the same thing here. These gems are very rare. So they're often cut and polished because they are used for jewelry. Again, I said you probably have a bracelet, or you might have a bracelet with a gem on it. You might have a necklace, some old lady earrings, because all of you kids are old ladies. So you're going to see these around. I have some pictures coming up on the next couple slides. So the differences between these gems, though, can be very slight. When we're working with elements, just adding in a little bit of another element actually changes the whole composition of the gem. We can have quartz of all different colors. We can turn quartz into amethyst with just a little bit of, I think it's magnesium. Yeah, right here, manganese, so close. So traces of manganese, geez Louise, in quartz can create amethyst. So I have a picture here on the next slide. Okay, so here are some common gems. Cat's eyes, diamond, emerald. You've most likely heard of at least diamond and emerald. Blue sapphire, pearl, yellow sapphire, ruby. That one down at the bottom that I don't know how to say. So these are just some common gems. And then here's quartz on the left. It's a clear, very crystal-y looking crystal gem. And then over here is amethyst. So you can see that it's actually kind of similarly shaped. It's a little less tall. And the quartz kind of has longer pieces sticking up, whereas the amethyst has shorter pieces. But the major difference here is the color. So adding in just that little bit of manganese changes the color of the quartz completely, and it actually makes it a different gem. So I think that's pretty interesting that just a little change in chemical composition can do something so drastic. So we're switching gears from gems to ores now. A mineral is considered an ore if it contains a useful substance that can be mined at a profit. That's the biggest thing here. That's what I kept reading in all of the textbooks. And, excuse me, that was my alarm. That's another alarm. Okay, so mined at a profit is what we need to focus on here. So, aluminum can be refined from bauxite. We're going to say it like that, okay? So there's an arrow up here because the picture is going to be coming in a second. So, aluminum is very rarely actually a native element. You're not just going to walk out in nature and find a big chunk of aluminum somewhere. You're going to have to find this bauxite ore, and then you're going to have to extract the aluminum out of it. So these products are worth more money than the cost of mining. Okay, so you can see here is a picture of bauxite. And then there's some little like pimple-looking dots of gray. That's actually the aluminum. So they would have to go in some kind of process. They might melt the rock down, they might crush it, they might use magnets, depending on what ore they are looking for. And they're going to extract that aluminum out of it. They're going to put it into sheets, and then you're going to use that aluminum to cover some cupcakes to bring into your favorite teacher, me. Okay. So these products are worth more money than the cost of mining. That's what makes an ore profitable. If digging out this chunk costs $10, but I can only sell the aluminum in it for $8, they're not going to waste that money. They just lost $2. Okay, so it's all about money here with ores. If this costs $10 to get out of the ground, but they're going to turn around and sell it for 20. They just made a profit. They just made money. So that makes it profitable for them. That makes it worth something. Think of the gold mining back in the old days of California, okay? All of the gold miners ran out there and they got all that gold out of the ground because it was cheap, because they could sell it for a lot of money. So, I don't know. Here we go. Oh boy. So ores of the element iron and aluminum are among the most abundant of the metallic mineral resources used every day. You use iron all over the place and you use aluminum all over the place. Aluminum cans for sodas, you drink out of those. Iron is like this giant steel beam. Any tall building, including the building you're in now, most likely has big iron support beams if we would break this building down to the bare bones. They are the most abundant metallic mineral resources. So metallic means metal. So there's some other ones that are non-metallic that are going to be used daily as well. Hematite and magnetite are important resources of iron. Iron is used in steel to construct buildings, bridges, automobiles, and trains. So just all that's going on here is to realize that an ore can be made of two different things together. So iron itself is an element. But we have two other minerals here that are playing in. We have this hematite, which is iron and oxygen mixed together. And then we have this magnetite, that's iron and more oxygen mixed together. You can see here with our subscripts, Fe2O3 versus Fe3O4. This is very high school chemistry. So we're just going to leave this slide kind of alone. If you get it, cool. If you don't, that's totally fine. So just what I need you to pull off this slide, maybe highlight it. Pull off that iron and aluminum are abundant, okay, and pull out that iron is used in steel along with some other minerals, okay? So there's a lot going on in this slide. There most likely won't be a test question from the slide just because it's a little tricky. I'm just going to tell you that straight up right now. So rare metals. Gold occurs in concentrations that are super low nowadays. Back in the gold rush day, there was a lot more of it. We didn't know about it. So once we found it, everyone ran out to California and they were like, hey, look, got this gold. So today in the 2000s, there's 1 part of gold to 4 billion parts rock. And that's another thing that's kind of tricky to visualize in your head. So I gave you a little analogy here. That's like having 1 red M&M in a giant bag of 4 billion blue ones. Okay, that's a huge difference. The odds of you finding that 1 red M&M is very unlikely. So that's how rare it is to find gold now. However, gold is still valuable enough that it is still mined for profit. So if we find an area of the United States that has gold or a chunk of gold like this here, we will still look for it because we use gold all over the place. We use it in jewelry. You use it in some parts of your telephone. They used to make teeth out of gold. Okay, if you know much about the Holocaust, I know they used gold back then. So it's worth looking for that 1 red M&M with gold. Other minerals, we wouldn't. It's not worth it. But we know that we can sell gold for a lot of money, so it's still profitable. That's the biggest thing I need you to get out here. Ores are profitable. Okay, so maybe make yourself a note of that. That's really the most important key thing here. So there's different ways that we can collect ores, and we're going to focus on this closer to the end of the unit, but we're just going to kind of touch on it right now. So many ores are obtained from large open pit mines. So ores are mined and contains unwanted material sometimes, along with the valuable material. So, I mean, think of this PowerPoint, for example. I have 16 slides I have to talk about. I just told you that the last slide is not going to be on your test. That's unwanted material. I didn't need to teach you that. But for some of you, it might pique your interest into high school chemistry. So you have to get rid of that unwanted material. You kind of have to sift through, what am I going to test you on in a few weeks versus what's just the junk to fill in between. Same thing here. They have to figure out what's valuable and what is just a chunk of rock that we don't actually need. So the waste rock or material must be removed before the ore can be used. So you might see around here, I know I grew up in West York School District, and there was a giant quarry near my house. We used to sneak into it and look at it all the time. Probably illegal. Okay, they dig down deep into the ground and they find whatever they're looking for. Maybe they found a big chunk of gold down in here. Maybe they found some other minerals such as sulfur or some other one that I can't think of right now because I'm tired. They're going to get rid of all the other junk though. We don't want the rock and the dirt and the clay. None of that's useful. Okay, so you can see we kind of have some piles built up. Here's just some pile of dirt and rock. Back here's some pile of dirt and rock. You can see that everything in the actual pit itself is black, gray, and white. So all of this brown junk, they don't want any of that. They're just going to throw it off to the side. So removing waste rock actually can be expensive, and in some cases it can be harmful to the environment. So I keep trying to reiterate here. Ores, they only care about profit. So if it costs a lot of money to get rid of the other junk, they're not going to do it. It's like that red M&M in the bag of blue ones. Okay, if you had to pay 100 people to help you look for that one red M&M, you're now losing profit because you have to pay people to help you look. So it's the same thing here. They want as much money as physically possible when they look for these ores. So the cost can get higher than the value of the desired material, and it no longer is classified as an ore. So minerals can move in or out of this ore status depending on what resources are around. Do we have that big truck that we need? Do we have the big backhoe? Do we have the manpower in order to go look for it? Is it still in demand? Maybe one day we're going to stop liking gold because it doesn't actually match a lot of our clothing and we're all going to shift to silver. So it really depends on the supply and demand thing. So here's another good example. If people stopped drinking soda and stopped using aluminum cans, the demand would go down. There's no longer a need for aluminum if we stopped drinking soda. So demand drives supply. If we humans, all of a sudden we want more Oreo cookies, guess what? They're going to make more Oreo cookies. But if all of a sudden we all decide, hey, no one's ever eating an Oreo cookie again, they're going to stop making them. It's no longer profitable. It's the same thing here. If we all take a strike on gold because it doesn't match, they will no longer look for gold in the earth anymore. Okay? So if there is no demand or need for the aluminum, they will no longer supply the aluminum. Okay, so it's the same thing no matter what you're looking for. Clothing, for example. Okay, everyone liked skinny jeans a couple years ago, and now we're all onto the high-waisted jeans. Specifically talking about ladies, but hey, gentlemen, you do you. Okay? You're not going to find a lot of skinny jeans out there that aren't high-waisted anymore because the supply or the demand right now is for the high-waisted jeans. So the suppliers, American Eagle, Hollister, H&M, they need to supply you with the jeans that you want right now, whatever's in fashion or in trend. So, moving quick, we're running out of time. So non-metallic mineral resources are used every day by humans as well. So you use it with road construction, driving, ceramic products, building stones, fertilizers. That's just to name a few things. The sand you played with as a kid is composed mostly of mineral quartz. So that sand that you played with on the beach actually has some value to it. I wouldn't suggest you sit through and try and find all the quartz pieces. You'll lose your mind. But there is some value in the sand that you played with as a kiddo. So I think that's pretty interesting. So common uses. You use minerals all over the place. I've given you some pretty big, not realistic examples, but let's bring it back home. So wooden pencils, that pencil that's in your hand right now, you're using graphite. That's a mineral. Sunscreen uses zincite. I'm very familiar with sunscreen, as I am a ginger. Mineral form of zinc oxide. So that's Zn is zinc, O is oxide. So that's that stuff that's lifeguards put on their nose to protect themselves. Toothpaste has a whole bunch of things in it. It has mica, fluorite, calcite, silica, has a whole bunch of minerals in it. These things are to help scratch the dirt off your teeth. It's helped whiten it. It's helped preventing cavities. It's a thickener, so it actually sticks to your toothbrush. So all of these things are used in common practice so that you can function better as a human. So some essential minerals are necessary for humans. You have major minerals that you need. Okay, calcium, chloride, magnesium, phosphorus, potassium, sodium, and sulfur. I'm really rushing. I got 2 more slides left. No pressure. Okay, you can pause and look at this picture. It tells you all sorts of stuff. Okay, so calcium is good for your muscles and bones. Magnesium is good for relaxing your muscles. Again, pause this video. Take a look over that. I think it's pretty interesting. Unfortunately, though, I'm running out of time. Then there are trace minerals, stuff that you need a little bit of, but not a whole lot. Okay, those include chromium, copper, fluoride, iodine, iron, manganese, molybdenum, selenium, and zinc. You get these from some of the foods you eat and some of the things you drink. I know Red Lion puts fluoride in their water. So you don't naturally produce any of these. You get them strictly from your diet. Okay, some breakfast cereals contain minerals. So I have 7 seconds. I'll post the last slide. Go back to Google Classroom and figure out what you need to do next.